All right, we're doing simple radical form. So remember, a radical is a square root sign. So all this means is a lot of times the assignment tells you to solve or evaluate and leave in simplest radical form. This one we just corrected, we had one that was like this. Similar to this, it wasn't exactly. So we were solving the equations, and when you square root this to get rid of the squared, and square root this, we wrote the answers as plus or minus 1.41, right? Mm-hmm. Square root of 2. Now, if it says to leave in simplest radical form, that means you don't write it as a decimal. You just leave it as the square root of 2. Okay? That way, when someone reads it, they know the answer is square root of 2, which is 1.41. They can figure it out on their calculator. So, most of them are simple. Like if you were to solve this, we would have to divide by 3, and you get x squared equals 9, and then you'd square root it. So x equals, now again, this is the thing that most people forget. Anytime you solve an equation that's a quadratic, if it's got a squared in there, there's 2 solutions. So the square root of 9 is plus or minus 3. This is a perfect square, so it just turns into a number. One example that I've seen people mess up, and I suppose it's just they're used to the square rooting, is, say you had one like this. You just got a square root, right? Mm-hmm. So x equals plus or minus 4. Yeah. Now it seems like this is really the only one people do this on, and maybe because these are both perfect squares. Sometimes people square root this again, and they put 2 for the answer. So they're just going one step too further. Once you square root something, it's no longer, that square root tells you an operation to do it. So once I do it, you're done. That's the answer. You don't do it again. That's kind of a common error I've seen throughout the years is on the 16 and 4. Now, simplest radical form. In order to simplify radicals, there's a couple things that you got to do to simplify. If any perfect squares go into the radical, it's not simplified. So now the perfect squares are, well, 1 is a perfect square, that doesn't do as much though. Square root of 4, square root of 9.
So that's where the 16 was.
1, 2,
Yep.
3, 4, 5, 6, 7, 8.
Shut up. Listen.
You don't have to have these memorized because the calculator will do it for you, but it's going to be a lot quicker for you if you remember the first 10 perfect squares. Square root of 4 is a perfect square because it's 2 times 2. Square root of 9 is a perfect square because it's 3 times 3. All the square roots in between there, like if you had an answer like this, x equals the square root of 5, that's simplified. Can't do anything more with it. Now, if you had the square root of 24, that is not simplified. So that's what we're doing today, is we're simplifying those that have to be. The reason why is because there is a perfect square that goes into it.
What one?
Which one?
5.
5 is not a perfect square.
6.
6 is not a perfect square.
4.
Here are the perfect squares.
Oh.
25.
25 doesn't go into 24.
16.
1.
Number 4.
4. 4 goes into 24 how many times? 6. So what you do is you break this up. We just write this into the square root of 4 times the square root of 6 is exactly the same as the square root of 24. Now what we do is, here's where the simplifying part goes. What is the square root of 4?
2.
2 times the square root of 6 is the simplified radical of the square root of 24.
So is that why like 5 doesn't work?
Right, 5 is not a perfect square. So you gotta have one number that is a perfect square. The other number is not gonna be a perfect square.
So if it's like a 24, 4 times 6, it feels like I don't know what number, but it feels like 3 times 9 or 3 times 5, 15 basically. If they wouldn't work at all.
Right, square root of 15 is simplified because none of these numbers go into 15. Square root of 30, is that simplified?
No.
Oh, 'cause you can put.
What perfect square goes into 30?
None.
None, so is it simplified?
Yeah.
Yes. Square root of 50, is this simplified?
No.
No, because which perfect square goes into it? 25, how many times? 2. So you write the two numbers like that, and you don't have to put the perfect square first, it's just, when they write them out, they always put the perfect square first. Square root of 25 is
5.
5. 5 times 5 is 25. So the square root of 2 is not a perfect square, so it just stays there. So the square root of 50 is the same as 5 times the square root of 2. You get the same number. It's just this is simplified, this is not simplified.
Right.
Another common one you're going to see is the square root of 80. Now, some of these are trial and error. You're going to want a calculator. A good point to start is around the halfway point. 49 is greater than half, 36 is under half. So if I took 80 divided by 36, I'll get a decimal. So I know that doesn't go into it. 80 divided by 25, I get a decimal. 80 divided by 16 is 5. So that tells me that 16 times 5 is 80. So once you find the two numbers, that's the hard part. Now the easy part is just to do your final simplifying. What's the third of 16? 4. Square roots of 5 is the simplified number of the square root of 80.
4 squared plus
So if you took 4 times the square root of 5 and pressed equals, and the square root of 80 and pressed equals, you'd get the same number. They're the same value. It's just this is simplified, this is not. Now if you have a bigger number, well this isn't so much bigger, but square root of 200. What perfect square goes into 200?
100.
100 times 2.
So 10 times 2.
So the square root of 100 is 10. So the simplified version is 10 square roots of 2 is the same as square root of 200. Now, sometimes you don't find the biggest perfect square. Someone might have picked 25 right away. 25 times 8 is also 200. And the square root of 25 is 5 square roots of 8. Which is correct, it's just, that's not simplified either. Because 4 goes into 8. So what happens is we just got to simplify this again.
5 to this square.
The 5 is going to stay there,
2.
and then 8 is square root of 4 times the square root of 2, right? 4 times 2 is 8. Square root of 4 is 2. And then 5 times 2 is 10 square roots of 2, which is the same way answer we got. It's just we didn't get it right away. We had to simplify twice. That's why if you find the biggest square root right away, it saves you a step. 100 times 2 is 10 square roots of 2. So some of these numbers, there's no magic way to do it. It's just trial and error. Looking at these Square root of 100, 100 doesn't go evenly into 448. 81, you can just check it, take 448 divided by 81. I get a decimal, so 81 doesn't work. 64, take 448 divided by 64, and I get a whole number, 7. That means 64 times 7 is 448. So what you're going to do is you're just going to start dividing by these numbers until you find one of them that goes in there evenly. So once you find those two, the next step should be the easy part. What does this make? Equal 8 square roots of 7. Because the square root of 64 is 8, square root of 7 just stays square root of 7 because it's simplified. So, that's one thing for simplifying. If any perfect squares go into the radical, it's not simplified. And then the second part is you can't have any radicals in the denominator of a fraction. A lot of the ones we do are simple. Like here's a real easy one. Square root of 4/9. You know, like when we did 24, we split it up into 4 times 6, right? Is the same as 24. So that made 2 square roots of 6. You can do the same thing with fractions. But the first thing you should kind of check is, can 4 divided by 9 reduce?
Yeah. No.
No, you can't. Nothing goes into 4 and 9. So what you can do is split this up. Square root of 4 on top, square root of 9 on the bottom. If everything is underneath the square root sign, you can just separate the two fraction parts and write it separate like that. Now it's pretty easy. What's the top going to equal?
2.
And what's the bottom going to equal? 3. Okay? If they had one like this, square root of 1136, split it up like this. Can the top, is that simplified? Can any of those go into 11? No. And what's the bottom? 6. So it's simplified because no perfect squares go into 11 and I don't have any radicals on the bottom. All right? So, square root of 27. Do any perfect squares go on to 27?
No.
Yes. Which ones? 1 goes into all of them, so you don't even need to worry. That doesn't help us at all. 9. 9 times 3. So what does this square root of 9 make? 3. Square roots of 3 is the simplified version of square root of 27. Then with the fractions, again you can split it up. Square root of 5 over to square root of 16. Square root of 5, does any perfect squares go into it? No. Square root of 16 is 4. Now this one's a little tougher. 48 over 75, neither of these are perfect squares, right?
Yes.
But this can be reduced. What number goes into 48 and 75?
6.
3.
3. Remember the shortcut to see how 3 goes into a number? Add them up. 4 and 8 is 12 and 3 goes into 12. 7 and 5 is 12 and 3 goes into 12. So 48 divided by 3 is 16. 75 divided by 3 is 25. So there I reduced it. Now they're both perfect squares, right? What's the square root of 16?
4.
And what's the square root of 25? 5. Square root of 12, which perfect square goes into it? 4 times 3. The square root of 4 is 2. So remember, this first number right here, you want it to be one of these. And these continue on, remember. Square root of 121, square root of 144, square root of 169. 63, which perfect square goes into 63? 9 times 7. And again, put the perfect square first.
3.
And then simplify it. Square root of 9 is 3. So 3 times the square root of 7 is the square root of 63. This one, since the whole thing is a square root, on top, square root of 13. Do any of these numbers go into 13?
No.
So that's just going to stay there. Square root of 36 is 6. These are not perfect squares, but we can reduce that. 3 goes into both of them. 16 and 27. Right? Now, square root of 16 is 4. Square root of 27, yep, that can be simplified. Square root of 9 times the square root of 3, which is 3 square roots of 3. So now that brings us to this part. This is not quite simplified because what's wrong with it? Square root in the bottom. Now, this is the easy way to fix that. Remember, if I took, I'm just picking any fraction, 3/8, and I took it times 1 over 1, am I changing the value of it?
No.
Because you're just taking it times 1. If I took it times 5 over 5, does it change the value?
No.
No, because what's 5 over 5?
1.
1. Anytime you take something times 1, it doesn't change its value. It just turns to 15 over 40, which if you simplified it, would simplify right back to 3/8. So, if you've got a radical in the bottom, all you got to do is take it times square root of 3 over the square root of 3. Whatever that square root is, just take it times that. If you did this on a calculator, square root of 3 times the square root of 3 will give you 3. The reason why is you multiply the insides. 3 times 3 is 9. And what is the square root of 9? 3. Okay? So these two multiplied make 3. But then you remember there's still this 3 out in front. So what's the bottom going to turn to? 9. So it actually equals square root of 3 over 9. Now these are a little bit more steps, so we're going to do these more tomorrow, and we're going to do the easier ones today. Okay? So the ones we're going to do today are the ones that have a perfect square on the bottom. The ones we're going to do tomorrow are the ones like this where it's going to end up with not a perfect square on the bottom, and then we got to simplify it.